constructs and conventions. Okay. So we'll learn what is this white space, operators, commands, identifiers, keywords, number specifications, and strings. So most of you might learn languages like C, C++, Python. There, I think you know about what is the basic language considered lexical convention. So again, here also we need to understand, and there are unique features are available that we can able to understand and distinguish between HTML and high-level languages. Okay. White space. Okay, so before starting, I just want to give you two things. Uh, so here I use the word design implementation and then design verification. Okay, so in HTML you have certain constructs, okay, which can be used only for the verification. That means only for the simulation. Those constructs cannot evaluate or yield any hardware. Okay, so it's only used for simulation purpose. There are few constructs that will be using like initial block, and then we'll use some system tasks. Those are all for simulation purpose only. Okay, and if I'm telling design verification, that means it cannot realize to any equivalent hardware logic. Okay, whereas if I'm telling design implementation, yes, of course, it will yield to an equivalent hardware. So this terminology you should understand. So not all the HTML code will yield a hardware. No. Okay. So HTML that you're going to write an RTL, that only you're going to yield a hardware. So that we'll understand. Okay. So I'll use these two terminologies during the presentation. Please try to understand. Design verification, that constructs will be used only for the simulation. Okay. White space. So in any design description, the white space or include to more readability. This again used for the design verification purpose, just like how you are using a print statement in C. So here we'll use that system task like $display. Okay. So I want to display the value of A, B, and then output Y. Okay. So I want to do this. This again I'll write it in the test bench. Okay. I'll write it in the test bench. Backslash B will give a blank space in the console, and then backslash T will give a tab space, and backslash N will be a new line. So this $display is again a system task. So this construct used for the design verification. Okay, so you can see in your simulator in the console window, this backslash N made that to the next line. Okay, after A, then B, after B, then Y. Okay, here operators. So Verilog is very rich in operator. We are going to deal all those. We have 10 plus operators are available. This slide gives you the overall classification of the operators. So the first category is unary operator, where it operates on a single operand. Okay. So here, this is an operator, and this is A is an operand. So here it operates on a single operand. So this string symbol is basically a NOT. So this is a NOT gate operator. It will perform a negation of it. So the out will be a negation of A. Fine. The second category is binary operator. Here it operates on two operands. So A is one operand and B is another operand, and this ampersand will perform a AND gate operation. Okay. Here it operates on two operands. That is only the ternary operators. Again, it operates on three operands. See here, you have S, A, and then B. How it works? Now, this is also called, conditional operator. When S is 1, your out is A. Okay. When S is 0, your out is B. Okay. So that's the mean. So when selection is that S is 1, your output is A, otherwise output is B. So it operates on 3 operands. So we call that as a ternary operator. Comments. So these are all very important in any programming language is concerned. So it gives a clear information what exactly the design that you're writing, the program that you're writing, and then and there what that particular block is basically the function that it's performing. The very important thing that you need to understand, today you are writing a code, and then after 1 month, if you are opening that code, you yourself cannot understand what you written earlier. Okay, so for better readability, you need to use these commands effectively. And when you're working as a team, so one of your team member have written the code and then he's sharing that code to others, then you should be able to understand what he or she has written, right? So then commands will play a very important role. So there is a statement like, it is very easy to write, the code freshly for the given specification rather than understanding the existing code. Okay. So this statement is applicable even for your J component, even for when you're doing a set conference related to your design based on very long history. So when you're downloading the code, understanding that code will take more time. It's better to understand the specification, write the code on your own. Okay, so that's what I want to convey here. Basically, it improves the readability and also helps in a good documentation. So there are two ways that I can be able to comment in Verilog. So one is one-line comment. For example, I have written z equal to x plus y. In this case, z equal to x plus y will be executable by the compiler, whereas this becomes a command. Okay, so 2/ is a one-line command. Okay, I can have a multiple line or a block of command. Here, this is a multiple line command. So uh, /asterisk to // then you can, whatever the statement that you have written, this entire statement is a command, not executable. In C also it is similar, right? When you have a multiple line commands, you cannot nest your command statement. See here, you open a multiple line command. This is again you're opening another multiple line command, and this is not treated as a command. It will show a syntax error. It's not a command. Okay. Identifiers. We'll use these identifiers for variables like inputs and outputs, and even for your program asset, we'll use those identifiers. So these are all used to define your language construct. These are referred to an object to be referenced in the design. So in terms of your input or output, okay, or the module as such. So identifiers are made of alphabets, numbers, underscore, and then a dollar symbol. Okay. So they start with always an alphabetic character or underscore. So what does that mean? It should not start with dollar symbol or a number. Okay. So this dollar symbol is already been reserved for the system task keywords. For example, we have seen dollar display. Okay. So you cannot use this as a identifier. Okay. You cannot use this as an identifier. So these are all case sensitive, and identifier differing in their case are distinct. For example, you are defining input A, comma B, and in the program while you are writing the expression, you are writing y equal to A and B. This A is not equal to this A, and this B is not equal to this B. Okay. So identifiers are case sensitive, that is, identifier differing in their case are distinct. So for example, you're making a count in a lower case, it treats that this count is a different variable and this count is a different variable. Here. So what are the allowed identifiers? So you can write name. These are an example. Okay. After that you can use comma, and then it can start with underscore. Okay, and then you can have full stop afterwards. Then you can have caps, and then you can have this, and then you can have name one, name underscore dollar. All these things are allowed. but this is not allowed. I cannot give a space A space B as a identifier. This is wrong. Okay, so the space is not allowed because of the blank, right? Okay. And dollar name, again it is not allowed because this dollar is reserved for a keyword system task. Okay. Again, it's not allowed. Why? It should not start with number. And again, this is also special character. This is also not allowed. Okay, special character like and again, you cannot have an expression as an identifier. A plus B, you cannot use that as an identifier. Okay. And overall, the keywords. So there are keywords part of language. You cannot use those keywords as an identifier. For example, module, input, output. Okay, so all these are all keywords. You cannot use this input again as a identifier. Okay, so here you can understand. So these are all the legal identifiers. Count. Okay, it can start with underscore. You can have number, but the first letter is again an alphabet. So this is also allowed. And the first letter again here it is alphabet, and then you can use the dollar symbol. This is also allowed. But it should not start with the dollar and it should not start with the number. These are illegal. So as I told, in your Verilog code, there are two identifiers are used. So here you can see this is called as an identifier. So this will be used during simulation. So you'll call this program for simulation. At that time, this an underscore gate will act as an identifier. So whatever the rules that we discussed is applied over here. So you need to remember. So generally what we'll tend to write when you're writing an AND gate, we'll always try to write AND. But AND you cannot write as a module name here because AND is a keyword. Just now I told these are all available as a keyword in Verilog. So you cannot use it. Okay. So the other way that I can use, in the codes as I told. So here A, B. So these are all the identifiers. Okay. The same rule, whatever we discussed, it should apply when you're using this identifiers. Okay. Clear? Verilog HTML is case sensitive. Okay. All the keywords in Verilog must be in the lowercase, and it can be written on a multiple lines or on a single line. So for example, I will write this code in the previous line, this code. So here I have written in a multiple line, and each line is terminated by a semicolon, right? Terminated by a, it's called semicolon. In module you won't use semicolon. Now I can write this input A comma B after this termination. So that's what this line states. So Verilog can be written across multiple line or on a single line also. So but always will, for readability purpose, we'll write it in a multiple lines. Okay. Keywords. The keywords define your language construct and it signifies an activity to be carried out. Okay. And it should be initiated or terminated. And as such, a programmer cannot use keyword for any purpose other than that is intended for. So for example, I told, right? So if you are telling input, input is a keyword. So you can use that to assign your ports to it. Apart from that, you cannot use that keyword for any other purpose. All the keywords in Verilog are in small letters. Okay. So as I told, it's case sensitive and they can be used as such. For example, module. So it signifies the beginning of your program, that is a module definition. Okay. End module, it signifies the end of your module definition. Then begin, it signifies the beginning of your block of statement. End, it again signifies the end of block statement. So this is equivalent to opening brace and close brace in your C language. Okay. If signifies a conditional activity to be checked. While. So these are all some of the keywords which you can use only for that particular purpose. You cannot use that for any other than it is intended for. So we are working on digital electronic circuits. When you talk about digital electronic circuits, then we need to talk about the number systems and how we are going to specify those number. So in digital, what are the number specification you have? Starting from binary.
0.
Yeah, 0 and 1. Yeah, you have any question? No. Okay. Binary, decimal, these are the number system, right? Hexadecimal, octal, right? Here in Verilog, so we'll define the numbers in a different way. So we call it as a sized numbers. So what does that mean? So this is a format that we will use. First size, then the base format, then the number. For example, I am writing 2. Okay. So this 2 represents a size. That means how many number of bits I am going to have. So it's a 2-bit size. And this backtick B stands for the base format. This B stands for binary. And if I'm using D, then it is decimal. If I'm using O, it is octal. If I'm using H, it is hexadecimal. And then the number. Now the tool will understand that it is a 2-bit binary 1 1. Suppose I am writing 1 and 1, then the tool will understand it as a 11 decimal. Okay, it won't understand this is a binary number. Okay, so that's why the sized number is very important. There is something called unsized number. In this case, I mentioned only B11. Still, it understand that this is a binary number and it is 1 and 1. The only thing is I have not mentioned the size. So this basically will instruct the the simulator to allocate the space. Okay, to hold it. So by default, it will allocate 32-bit or 64-bit depending upon the compiler. Okay. So size, as I told, it must be always in decimal. Okay. So it can be either 1-bit or 2-bit or 4-bit or 8-bit or 6-bit, so and so. You cannot have 6.5. That's wrong. Okay. So it should be always in a decimal. So size should be in decimal, representing your number of bits. Then the base format, small b or capital B you can use. This is for binary, and this is for decimal, and this is for octal, and this is for hexadecimal. So the numbers without a base format are decimal by default. So that's what I told. When you're writing y equal to 11, so y equal to 11, this will interpret as a decimal. It won't treat that as a binary 1 1. Okay. So here you can able to see this negative number is not allowed for other system except for decimal number. That we'll discuss little later. Okay. So generally we'll use 2's complement form to represent your negative number. Okay. So this 4 represents a size. This 4 represents a size. If it presents the decimal number in this field signifies the bit width of the number. Okay. So if it is not present, the width will be assigned by default value by the compiler. That's what I told, by default 32-bit or 64-bit by the compiler. Now this backtick B, okay, is a base format. Again, B for binary, D for decimal, O for octal, and H for hexadecimal. Okay. And coming to this number, this field signifies the value of a number. So for binary, you will be having 0, 1. Apart from that, you have X and Z. So these are all very important when you are describing any digital electronic circuits. We should not ignore X for don't care and Z for high impedance. Okay, clear? And for octal, 0 to 7 and X and Z can be used. And for hexadecimal, all numerals 0 to 7 and 0 to 9, then A, B, C, D, E, and F, then X and Z, and all numerals X and Z for decimal. So this is how you will be representing a number. Please always remember, a good designer will always represent in terms of sized numbers only. Okay. So here some of the examples for you. This is a 4-bit binary 1111, right? And this is 12-bit hexadecimal number, and this is a 16-bit decimal number. And see here, this is a unsized number. This is a 32-bit decimal number by default 2, 3, 4, 5, 6. And this is a by default 32 or 64-bit by compiler number, hexadecimal number, and this is a octal number. Okay. This is very important, as I told. There are two cases. One is high impedance, the other one is X. Will I get X high impedance state in my design? Yes, of course. Unknowingly, there are many situations you will end up with this. You, as a designer, must be aware of it, whether my output logic is, whether I'm getting a stable output or I'm getting any high impedance state or I'm getting an unknown state. So I'll quickly give you an example how you get a situation like this. So you have a logic something like this. So when I'm giving 0 and 0, I'll be getting 0 here. I'm also giving 0, 0 here, same A and B, 0. So what I'll be expecting here, 0. Again, I'm giving 1 and 1. Again, I'll be getting 1 here and 1 here. And then I'm giving 0, 1 and then 0, 1. So this will give 1 and this gives 0. Now what is the value of y?
Z
Yes.
impedance.
One,
Hmm?
one sir.
1. How? Because 1 is higher than 0, right? That's right.
It's unknown, sir.
So
Unknown or
it's
I.
basically a x unknown. Subject to the condition, the drive strength of this net and this net are same. Okay. So we need to talk about drive strength values of these nets. Okay. Clear? So when both these wires, because these two, what basically this, the output of this AND gate and output of this OR gate is driving a single net here, Y net. Okay. So when you are trying to force a two different value on a same net, basically it is a unknown. So which will be driven based on the property of this net Y. Okay, the strength of the net Y. Accordingly, it will choose the value. When you are telling it is strong 1, then 1 will be passed. When you are telling strong 0, then 0 will be passed. Otherwise, if you are not mentioning the strength of the signal, it will be end up in X. Okay. Clear? Like this, there are many application where you will be end up with this kind of situation. And high impedance, it's a floating state. So you'll be having a gate, your output is connected to either VDD or your output is connected to a ground. Okay, so this is called a floating state. Okay, so even in your inverters, you might study the crowbar condition, where when you have as a switch, okay, so your at a given condition, both the switch on off. When both the switch are off in your inverter, then we call that as a floating condition. Okay. And the other way, other good example for this is you have a buffer, input, output, and enable. So as long as enable is 1, if your input is 1, output is 1, and if input is 0, output is 0. When enable is 0, whatever might be the input, your output will be at high impedance. So that's why we call that as a tri-state buffer. Okay. Okay. So here you can see I'm representing this high impedance number. So it shows that it is a 32-bit binary, and then I'm not representing 32Z. So I'm representing only one Z. So that means this will be self-adding property. So all the remaining bits are Z. Okay, and here also for X. So the self-adding property is applicable for X and Z, not for the binary or other number system. So this self-adding is applicable only for this. Okay. And here you can see, as I told, in Verilog there are 4 values and 8 strength levels to model your real design. So this is how the strength increases, starting from high impedance, small, medium, weak, large, full, strong, supply. Okay. So I was talking about the drive strength on a net. So if you're representing a drive strength accordingly, that value will be written. Okay. So here you can see this is a 5-bit octal number, and this is a 4-bit decimal number, and this is 7-bit hexadecimal, where it has a self-adding property. All the 7 bits are X. Now here it is a 4-bit hexadecimal high impedance, and this is not legal. You cannot represent your negative number in this way. Okay, it's a illegal way of representing it. So here the space is allowed between the number and the base format, and the base format, the size and the base format, and the base format and the number. So this is allowed. Okay. Now you can see in this example, there should not be any space between the button and the base format. So this is wrong. So this shows a syntax error. Okay. So while you're typing in the simulator, these are the common mistakes that you'll do. So this is again a syntax error. Okay. Now here is an example. I'm using a 10-bit binary, and then this 10 represents the size, and this represents a base format binary, and then I'm representing 1 0. But here the size that I mentioned is 10, but the number which I represent is only a 2-bit. What will happen to the remaining bits? All will be self-added with zeros. Okay. So here remaining 8 bits are added with 0. Now here you can see it is a 3-bit, and then you have a 8-bit number. So this underscore is for the readability. For example, I am writing a number 10010000100 like this. Could I able to understand by reading it quickly that it's how many bit number? So just for readability, I will be writing like this. I will use underscore, again underscore, again underscore, like this. So now I can easily understand 4, 8, 12, and then 2. 14 bits I can able to. So both are same. Okay, I can represent in this way just for readability. So this is equivalent to this number. Now in this case, how many bits I represented? 1001 underscore 0011. So totally 8 bits. But as far as the size is concerned, I mentioned as a 3-bit number. Am I right? So now what will happen? The compiler will understand this is a 3-bit number only, but I have represent 8-bit. So starting from the LSB, the least significant bit, it will take this 3-bit alone, 0, 1, 1. What will happen to the remaining 5 bits? It will get truncated, okay, automatically. So only this 3 bits will be represented. Okay, we will start with. Am I audible now?
Yes, sir.
Yes, sir.
Yes. Okay, thank you. So as I told, integers can be represented in 2 ways. One is signed, the other one is unsigned. So here you can see these are all the valid number specification for integers. Okay, and mostly it is advisable to use integers during test benches. Okay, we'll try to avoid use this. Later we will see why it is so. And generally we discuss like this negative numbers. For decimal, it is acceptable. Okay. For other number system, it's always a 2's complement form. Okay. We'll discuss about it. Don't worry. When we're discussing about data type, then we need to work on this number system. And I will take an example for and then I'll explain. Okay. So these are the valid number specification for integer. And coming to the these are all the non-decimal representation, which is not permissible. 2a, b8, all these things. These are all not permissible as an integer. And another important thing is this is why we use this as in test bench, not in the design. By default, all your circuit synthesizer will assign 32 bits of it. Okay, so in some cases it may be 64 also, depending on the compiler. These are all the about the integer. Can I represent a real number in Verilog STL? Yes, we can. It can be represented in a decimal or a scientific notation. So here the decimal has this form 3.2, and in a scientific form it is 4.3 E2. So where 4.3 is your mantissa and 2 is your exponent form, right? So which is equivalent to 430, right? So these are all the way that we will do it, and then we have to use real data type. So at that time we'll discuss more on how to use these real numbers. Okay, but generally for design purpose we won't use these real numbers. Okay, we'll always try to do return integers or other number system. Real number, very rare case we'll use it. Okay, strings. It's a sequence of character which are enclosed in double quotes. So Verilog classes are very interesting within double quotes, right? And here the space are not ignored. So you must have space here, and strings cannot be on a multiple line. So starting a double colon, Verilog, class like that you cannot have. Okay, it should be on a single line, and we'll use this in the yeah.
Last FPG assignment, there was a questions about strings.
I'm coming to the assignment. Don't worry. I will answer for your assignment question.
Okay, sir.
So mostly like we'll use test bench. Of course, we can use in design also. So you can able to see strings in expressions. So what does that mean? For example, I am assigning, this is basically a string within double quotes, right? And I'm assigning to a variable called p. So that means it treats this equivalent ASCII value. That ASCII value will be assigned to p. So for example, for n, you will be having an equivalent 8-bit number 0, 1, 1, 0, 1, 1, 1, 0, and then 0, 1, 1, 1, 0, 1, 0, 1 for u, and this is for b, and sorry m, and this is for b. So this 32-bit value will be now assigned to p. Okay, here. So these are all the 8 bits, and totally 32 bits are now assigned to p. So you can use the strings in expressions also. So coming to the escaped identifier. In the earlier case, we saw the rule that an identifier should not start with a number, should not start with a dollar symbol, and then you should not use a keywords and special characters. So and so we discussed, right? But there is something called escaped identifier, where it allows any character to be used, even ASCII values and all. Okay, but here the rule is it should begin with backslash. Okay, and it should be terminated with a white space. These two are the important rule for using the escape identifier. For example, character like comma, parenthesis, and semicolon, all these will be treated as a part of identifier if you are not giving a white space. Okay, see here example. In this case, backslash Q, and then I'm using tilde symbol. This is a special character. Now this will be treated as an identifier. Okay, so we call it as an escape identifier, and there is a white space you can able to see here. If you are putting a comma here, then what will happen? This comma also will be considered, and that will treat as an identifier. Okay, so always when you are using an escape identifier, you should terminate the escape identifier with a white space. Otherwise, the character should follow the identifier also, will be part of it. Okay, so you can use in this way the escape identifier. Yes, coming to the test for understanding question, which we had yesterday. Multiple line commands can be nested. What's your answer?
False.
False, right?
False.
False,
You
sir.
can, you cannot nest a multiple line command. What about the list of? I asked 4 rules. Okay. Anyhow, I'll list out. One is it should not start with a number. It should not start with a dollar symbol. It should not have a special character. It should not be a keyword, and you cannot have expressions. So any 4 these things if you written, well and good. Okay. What is the answer for this? Very low. Is case insensitive?
False, sir.
So it is case
False.
sensitive, right? So it's false. Identify the valid number specification. Multiple answers are allowed in this question. So one tick B0, it's a size number, right? It is correct. And this is wrong. You cannot represent a negative number with this. Again, this is wrong. You should not have a space between backtick and B. And this is allowed. Even though the size is 3, it has a self-padding property, right? This is correct. And again, this is also correct. It is also having a self-adding property with 0, 0, 1, 0, 0. So this is the equivalent number for this. Got it? And strings can be given in multiple lines. False. Okay. Vanilla HTL. To begin with, we'll understand the basic language